Is n to the power of 7 minus n divisible by 7 if n is an integer? Let's find out. First, we have to do some factoring. N to the power of 7 minus n can be rewritten as follows. It is n times n to the power of 6 minus 1, which can be simplified further as n times n to the power of 3 minus 1 times n to the power of 3 plus 1. And we can thus obtain n times n minus 1 times n to the power of 2 plus n plus 1 times n plus 1 times n to the power of 2 minus n plus 1. And we can shuffle the order of the terms, and we can write down n minus 1 times n plus 1 times n to the power of 2 minus n minus 1 times n to the power of 2 plus n plus 1. Now that we've simplified our expression, we can start thinking about division. If any of these terms is divisible by 7, then the whole thing will be divisible by 7. So we have to investigate. The first possibility is that n itself is divisible by 7. This is obviously the easiest thing, and this means that everything's alright. However, the other options are that it is not divisible by 7, but when we divide it by 7, we get a remainder. And this remainder can be 1, 2, 3, 4, 5, or 6. Therefore, if we manage to prove that for any of these possible remainders we get at least one term that is divisible by 7, our job will be done. So let's start with 1. If n divided by 7 yields something with a remainder of 1, this means that n minus 1 will be divisible by 7. For example, let's say that n is 8. n divided by 7 yields 1 with a remainder of 1, but n minus 1 would be 8 minus 1, which is 7, and 7 is indeed divisible by 7. This one was easy. Let's move on to a remainder of 2. If the remainder is 2, we can write down that n equals 7 times k plus 2, where k is an integer. And therefore, we can write down that n squared equals 49k squared plus 2 times 2 times 7, which is 28k, plus 2 squared, which is 4. And we remember that one of our terms is n squared plus n plus 1, and this one would equal 49k squared plus 28k plus 4 plus 7k plus 2, which is n, and then plus 1. And when we simplify this, we get 49k squared plus 35k plus 7. We now note that 7 is a common factor of this expression, because 49 is 7 times 7, 35 is 5 times 7, and 7 is just 7. So every single one of these terms is divisible by 7, therefore the whole expression is divisible by 7. It's time to investigate what happens if after dividing n by 7 we get a remainder of 3. Similarly to what we did with the remainder of 2, we can write down that n equals 7k plus 3, and k is again an integer. And now we have to find what n to the power of 2 equals to, and it is 49k squared plus 2 times 7 times 3k, which is 42k, plus 3 squared, which is 9. And we remember that one of our terms was n squared minus n plus 1, and this one equals 49k squared plus 42k plus 9 minus 7k minus 3 plus 1. And when we group this, we obtain 49k squared plus 35k and plus 7 again. And as you see, 49 is 7 times 7, 35 is 5 times 7, and 7 is just 7. Again, every single term of this expression is divisible by 7, therefore the whole thing is divisible by 7. So we write it down. The cases for remainders of 4 and 5 are very similar. For 4, we get that n again is 7k plus 4, and we obtain that n squared plus n plus 1 equals 49k squared plus 63k plus 21. Again, we have 7 times 7, 9 times 7, and 3 times 7 in each term. Therefore, 7 is a common factor of this expression. And for 5, we get that n squared minus n plus 1 equals 49k squared plus 63k plus 21. And again, 7 is a common factor of this expression, and therefore the whole thing is divisible by 7. And there's one more case to investigate. What happens if, after dividing n by 7, we get a remainder of 6? Well, 6 is 1 less than 7, and therefore n plus 1 would be divisible by 7. We have now exhausted all possibilities and can therefore assert that n to the power of 7 minus n is divisible by 7 provided that n is an integer.